Thanks everyone for joining today for our presentation on graphs in the automotive and manufacturing industry. So today we're going to start with a general overview about graphs and specifically about Neo4j for anyone who is new to this area, who's not familiar with graphs or familiar with what we do at Neo4j. Then we're going to dive into an overview of some of the types of data that an automotive or a manufacturing company might have. Often this will live in different systems and it'll cover different areas of the business. We'll talk about how these can be linked together using the graph. Then we'll look at some specific use cases, some examples of combining that data into a graph. So we'll talk about supply chain management. We'll talk about warranty and warranty analytics. Customer 360 view, and then knowledge graphs, and we'll touch on a few others that are maybe less specific to automotive and manufacturing, but would still be applicable in those industries. And as Alexander said, at the end, we'll have a bit of time for Q&A, so please do ask any questions that you have. Okay, so first our introduction to graphs and Neo4j. What is a graph database? So we'll define that by comparing it to relational databases, which have been around for decades and most people are familiar with. So relational databases are table oriented, right? Rows and columns. So every row is a thing, columns are attributes of those things, and then you link together different tables or different types of objects in your database using joins and foreign keys or link tables. So very similar to Excel, kind of very common data storage and processing model, and you query that using SQL. Neo4j takes a different approach to data. So Neo4j is a graph database. And what this means is we focus on the connections between data. So rather than storing everything in this kind of square shape of rows and columns, things are linked together dynamically and directly. So there's no joins, no link tables. When you write data to Neo4j, you link it directly to the things that they're related to, and then that allows you to understand those relationships and follow them very easily, very intuitively. And when you talk about performance at scale and very large data sets. And we'll take a look later on at some examples of that to really bring that idea of connected data to life. And then compared to relational databases and SQL, the query language for Neo4j is Cypher. So it looks a little bit different. It's specifically designed for working with graph data and the patterns that can come up in that connected data. Okay. And this model, this graph database approach is really very powerful in today's era of lots and lots of data, a high volume of data, a high velocity of data, and high variety of data, where you have data coming from all different places, or you might have data stored in all sorts of different places in your business, different physical data silos, different lines of business. Being able to combine that data together and understand the relationships that are inherent but maybe not very easily visible using a different approach is extremely powerful, right? And we think that this will drive the next wave of competitive advantage, right? Companies who are taking graph approaches to some of their problems are seeing lots of benefit. And we'll take a look specifically at the automotive industry later on about how we can use this connected data to drive that sort of competitive advantage and really get new value out of your data. So a little bit about us. Neo4j is the #1 database for connected data. We are the leaders in the graph database field. We kind of created the category really. We are a native graph database, which means that's what we do is graphs. So from the file system all the way up, it's all graphs. There's no translation layer, there's no different underlying model. We store data as graphs, we process data as graphs, we present data as graphs, and we do that in the same way that you would expect any other enterprise-grade database to do it. So we can do it at scale, we can do it reliably, so you won't lose your data. We're ACID compliant, and it's a very agile environment in which to work. So growing, starting with a small Neo4j installation and then growing that as you have more data and more use cases come on is quite easy to do. Just a quick example of some of the terms of a graph and what a graph database will look like, so that it makes sense when we look at some of our examples later. A graph database is really made up of three main elements. So first we have nodes. And nodes are usually things, they're nouns, objects. And here we're representing them as circles. That's kind of the typical way of showing them. And we have three nodes, and nodes can be labeled, so you can give them a label, a tag, so that you can work with them, make it easier to classify them. So here we have two types of nodes, two node labels. We have person nodes, two of them, and we have one car node. Next, there's properties. So properties are attributes of those things. They're key value pairs, really. So you can see the person on the left has a name property, which is Dan. He has a born property, which is May 29th, 1970. And there's a Twitter property for that node as well, which is @Dan. So that's his Twitter handle. On the right, we have another node. The name property for that node is Anne. She was born December 5th, 1975. We don't have her Twitter handle, and that's okay. It's not like in a relational database where every row has the same number of columns and you have to stick a null value in that column. If you don't have a particular property type, you just don't add it to that node. Out of the box, Neo4j doesn't really enforce that every node with the label has to have exactly the same properties and the same types. And then finally, the real power of all this is by combining these nodes and properties together with relationships. So you can see here we have a number of relationships between these two people. You can see Dan loves Anne loves Dan, and Dan lives with Anne. So these show how these nodes are related to each other. When you write a relationship to the database in Neo4j, it always has a direction. And sometimes that's important and sometimes it's less so. So here we see that Dan loves Anne, and that moves in that direction from left to right. It's important to know that Anne also loves Dan, which is why we have another relationship going the other way, because it would be possible for Dan to love Anne, but sadly not for her to love him back, which is not the case here. However, Dan lives with Anne, again, moving left to right. It would be impossible for Dan to live with Anne and Anne not to live with Dan. So in that case, we don't need a relationship going in both directions. It's enough to just have the one relationship, and then we can ignore that direction when we query the data. And then you can see as well, you can have properties on relationships. So not just properties on nodes, properties on relationships. We can see Anne owns the Volvo at the bottom here. And Dan drives that car, and he has driven it since January 10th, 2011. So that relationship has a start date. It could have an end date, any number of other properties as well. So those three things, nodes, relationship, and properties, are what make up the graph, the property graph database model. And that gives us everything we need to build really complex and really rich data sets that we can then query to gain new insights. Okay. So now we'll take a look specifically at some of the types of data that an automotive company or a manufacturing company might have. We are kind of focusing specifically on automotive in this particular discussion as we go through some of these use case examples, but I think there's probably quite a bit of overlap between automotive and any other type of manufacturing company. We just chose automotive because it's probably easier for most people to understand and gives us something to go into a bit more detail. So first, we have organizational data. So this would be data internal to your company. You probably have lots of documentation in your own company, processes that you follow, information about your different facilities, your different factories or warehouses, and so on. You might have an organizational hierarchy, not just in terms of people management, but also in terms of how different departments or lines of business fit together and interact. KPIs and reports are quite important. Obviously go to leadership, go to the board, determine lots of important things, right? Lots of important decisions are made on those KPIs and reports. So it's interesting to know how that data gets generated, where it comes from. And then there's your systems and your databases, your IT infrastructure, where data is held, where the documentation is held, so on and so forth. Then we have data about products. So these are, the things that you make and you sell. They'll have their own documentation and perhaps their own processes, maybe for how you deal with customer contacts or claims, or how you build your products. Then there's the product details. So everything about that product that either your customer might want to know, or you might want to know. You could have a product hierarchy. So this could be families of products. It could also be brands. So you might have quite a complex setup between those things. And then there's bills of materials, which could almost be a category in itself. We could do a whole session about bills of materials, I think, because they're so naturally a fit for the graph, right? If you wanted to draw a bill of materials, all the components that go into a thing, how those components fit together, it would naturally form a graph. So here we have bills of materials alongside the products, so that you can keep track of all the things that go into your various products. And of course, there can be multiple bills of materials, right? So there could be an engineering bill of materials, there could be a sales bill of materials, there could be kind of an as is and as was view of the bill of materials as things are maintained over time or get upgraded. So quite a lot of data can be held in there. And then we have customer data, and this can be a little bit of a tricky one. Often automotive companies might not have, manufacturer of cars might not have a direct relationship with many of their customers because those customers will come through a dealer. So sometimes you could consider customer data as third-party data, but here we'll look at whatever data you do have about customers, or maybe if you're not an automotive company, you might have a different set of relationships with your customers. That could be personal data, it could be a person, or it could be a company. So in this case, if we have a company who buys fleets of cars from you, and then relationships between those customers. So where you might know either persons are related to each other or persons are related to companies. You might have a personal customer who works at a corporate customer, so on and so forth. Then there's third-party data. So we mentioned dealer data, data about your partners, the dealer network that you work with. Social media posts, information you might get, publicly from Instagram or Twitter or Facebook. And then there's market data, and this could cover lots of things. It could be market data about your competitors. It could be press releases and news stories and so on about you or about your products. Or it could be information about your suppliers, macroeconomic data, tariff information, things like this. Then we've separated out some specific event data. So these are kind of things that happen in time. You might have sensor data or telematics data, and this, of course, is only growing as the concept of IoT and attaching sensors to everything really takes off. So every time you interact with a vehicle or when your dealers interact with a vehicle, you might have a chance to get some of the sensor data or telematics data, or indeed if there's some other way of transmitting that data from the vehicle or from a customer's device. There are individual warranty claims. These would come through the dealer, but as an event in time, we'll kind of treat them a little bit separately. And then you might have a customer contact. So these are calls to your call center or emails or what have you, individual contacts between you and your customers. And then finally, we have supply chain data. So this might be information about your suppliers from who you buy raw materials or parts. There's logistics data, so how these things move about, what your options are, how long they take, costing, so on and so forth. And then I've included here as well inventory data. So this is data that you have about parts or materials that you have in inventory, and maybe in one of your facilities that you've purchased already and have available to you in some way, whether it needs to be shipped or not. Okay, so this is not a comprehensive list of all the data that a manufacturing or an automotive company might have, but it's certainly indicative, and it gives us enough to then drill into an example of how we might be able to combine these different parts of pieces of data in a graph to achieve certain use cases. Okay, so we'll start with supply chain. So we'll look at some ways that we can combine the data that we've already talked about to manage our supply chain, right? To have an overview of it and be able to interact with that data to make decisions. So in this kind of yellow color over here on the right, we have a lot of information about suppliers. And so here we have suppliers that we buy components from. They supply us with components. We can see the cost of those components, what options we have for shipping. We already have some inventory of them, so we can see we have some inventory here in facility A, some inventory here in facility B. We know that the component that we're talking about here is the same as another component. So maybe you have different names for these components, or you label them differently because they come from a different supplier, but the form, fit, and function is the same, so they can be used interchangeably in the same way. And then we have here kind of a basic way of demonstrating a BOM. So we have a component goes into assemblies. That's probably much deeper in a real BOM, but just to kind of give you a feel for how you might take individual components or individual parts and combine them and work your way up the tree until you can start to understand how many orders you might already have taken that include that component. As well as how many vehicles you've already sold that have that component, which brings us kind of more into our product data set, right? So we have our BOM, our component and assembly groupings. We have some information about orders and vehicles already made, the product that they go in, and then of course that can be chained up to a view of the product line. So ultimately, this kind of gives us a way of understanding the supplier and how that can impact all the way up through to orders, to products. We can take a look at sales figures for what we've sold already, sales forecasts for what we expect to sell, and then this gives us the opportunity to to start understanding how we might want to make purchase decisions, right? Take what we know we have in inventory, subtract that from demand, right, which is more here on the left-hand side. How many orders we know we have to fulfill, how many we're forecasting we'll need to fulfill, and then make a decision between different suppliers, maybe based on the shipping cost, the cost of the parts, the contract agreement that we might have with them, as well as any impact of, like I said, tariffs or things like this, right? So it really gives us an end-to-end view of demand through to supply, and gives us lots of options for how we manage that. Down here in the lower left, we have sort of our link to what will be another use case. So here we've shown that there can be some claims. That claim can be related to a particular component, right? There might be a number of customers who have made similar claim related to a fault in the same component. And this gives us a way of approaching suppliers perhaps if we think that there are a number of claims that are down to a fault in the component we're getting from them. Right, so gives us the data we need to be able to trace all the way from customers and the claims through to the components from a particular supplier, and then lets us understand whether we have other options, for replacing those components, buying from a different supplier, perhaps that won't be faulty in future. So some of the ways we might use this type of a graph. So can we use it to help improve ordering and procurement processes? Absolutely. Having this data at hand and understanding these relationships, at the data level, can really speed up the process of procurement and ordering, and kind of understanding what you need to buy based on forecasting. Right? If that's a manual process, if that has to cross a number of different systems, that can take a really, really long time to do. Right? Here we're looking at instant access, instant insights, because we have that full view all the way from the left, demand, all the way through to the right, where the supply is. Can this type of a graph help us save money on orders? Absolutely. If you understand, especially if you have a longer view of demand and how that compares to your inventory and how much you're going to have to buy in a particular time period, it could let you leverage economies of scale. So maybe you're making smaller orders more regularly because you can't execute this kind of long-term view across that whole supply chain. But if you do have that longer view, which the graph can help you visualize, then you can buy in bulk, you can make more intelligent buying decisions, and therefore you can save money. Can you optimize your inventory using the graph? Absolutely. Again, when you know how many of each part you have available to you, where those are, how long they'll take to get to you, and what vehicles those are going to have to go in terms of your forecast. You can then move your inventory about so that it's in the right place at the right time. You can use that to fill demand rather than making fresh purchases and leaving your inventory sitting where it is. And then you could certainly refine your inventory planning so that you don't hold quite so much, right? When you have, again, that view of your forecast, and how that's going to play out in terms of how many parts you're going to need, then you can plan your inventory effectively and not buy more than you're going to need and not have to store more than you're going to need. And can the graph help you with comparative analysis of suppliers and their products? Again, absolutely yes. When you have that view of the suppliers against all the parts and the components that you're using, you can compare those to warranty claims, again, to see the kind of fault rate from different suppliers. You can understand, how they compare in terms of logistics, whether there's any tariffs or any other regulatory compliance issues you might have to face. When you have that whole view, you can make a much more informed decision about which suppliers you work with and which of their products you purchase. Now, warranty claims and claims analytics. So here in the center of the graph, kind of at the heart of all of this, is our event data relating to the claim. That claim is for a particular fault, which could hopefully ultimately be related, be associated with particular parts or a particular component. Right? So we can then start to understand how many of these things have happened, right, by looking in the graph for other claims that are for the same fault, right? And then we can start to understand if that part is faulty, because we've got a lot of claims here for it, how many other vehicles is that part in? can we predict how many of them might be likely to fail, right, based on how many claims there are against how many vehicles there are out there, and the velocity, how rapidly these claims are coming in, and then start to predict, are we likely to get more claims? Is this likely to be an expensive issue? How can we resolve that more quickly if we think that's what's going to happen? We can then take a look at the supplier that these parts are coming from. Again, this is kind of our link here to the previous slide where we talked about supply chain management, how we can start tracing back claims through to suppliers, and then have that conversation with supplier if we think that their parts are faulty. We can also take a look at customer and dealer behavior, again related to claims, in particular faults. Fraud is a strong word, and dealers and automotive manufacturers are more partners than anything else. So we don't really want to use the word warranty fraud here, but there could be cases where we think the claim is it may be inflated. It's for more than we think it should be. We have the documentation about the fault. Maybe this is something we've documented and said, when this happens, here are the parts you need to fix it, and here's the approach and how long it should take, and so on and so forth. So we can start looking for whether or not there are outliers in these claims, whether any of the dealers, their claims for that particular fault are out of line with kind of the average of everyone else, and whether or not we think that means they might not be following the documentation correctly or making the repair correctly. And so maybe we need to have a conversation with them about that. Could also be, we might see patterns of claims, maybe as the warranty is coming to its end, and in the final 4 months of the warranty, we might see a burst of cosmetic issues or specific faults consistently being addressed within that time frame, which we might want to have a look at and investigate. And then again, we have potentially telematics data and sensor data, which might help illuminate some of these faults and understand if there's a particular pattern of either driver behavior or things happening in the car that lead up to a particular fault that we can then forecast for. Then, of course, we do have some information here as well about the vehicle in question. So, we can hopefully have a full view of everything that's gone into it. We might have the history of repairs. We know what parts have been in there over time, so we can take a look historically what's happened to that vehicle and understand the impact that history can have on this individual claim. We'll need to know, how that car is configured, so what options it has, what makes it different than all the other cars, and then, of course, we do have the basic information about that particular product, what the generic definition for that vehicle might be. And then finally, we have social media down here, which again could take investigation into a warranty claim into account. If you can find social media posts about something that happened, or maybe do some sentiment analysis and social media posts leading up to that claim, can also help illuminate the history and context for that claim. So how can we use this type of warranty analytics graph? So can we find patterns in the graph indicating inappropriate claims or warranty fraud? Absolutely. And once we find those patterns, we can then keep an eye out for them, right? So we can take a look. What are there patterns? Are there things that lead up to this particular type of claim, or to this claim being inflated or taking too long, or what have you? When we find that pattern, we can look for other instances of that pattern in the database, so look historically through. And we can also then create a trigger, keep an eye out for formations of that pattern in future, so that we can be proactive before the situation ends up reaching the point of the inappropriate claim. Can we use the graph to help predict future claims? Yes, absolutely. Again, when we understand the pattern around a claim, be that telematics data and sensor data, other repairs that have gone that have led up to that, the parts that have been involved. Again, when we start to see this pattern forming, then we can predict claims happening in future. Right? And so that can help you manage your warranty risk, or indeed in serious cases, your recall risk, right? You start to understand how big the problem is likely to be, how quickly you can put an engineering fix in place so that it doesn't get built into any new cars, how big the population is that's likely to be affected, and then you can take steps proactively to deal with that situation. Yes, I think we've already talked about how we can use the graph to help understand whether faults might be caused by supplier issues. Right? So we have that full view of claims, of parts, and the bill of materials, and how that maps to suppliers. It gives us a much better view of whether or not supplier issues might be at play, and helps inform how we react to them. Okay, next we'll take a look at Customer 360 View. So this is, of course, a hot topic across most industries. And the goal really is to develop a holistic view of your customer so that you have ready access to all the information that you have about them and understand how it fits together. So, of course, at the heart of the graph, we have our customer. We can understand the relationship, as we mentioned before, to other customers. This customer might work for one of your other corporate customers. They could be family members, so maybe husbands, wives, children, all have cars from the same company. We have contract information maybe between that customer and you. We can see not only information about their current vehicle, its current BOM and how that's been serviced, what options they have, product definition, so on and so forth, but we can see the information they have like that about any previous vehicles they've owned. So we can see historically what vehicles they purchased, what options those had, their past claims, that whole history of all their vehicles that we might have. And that could include sensor data, telematics data, claims data, any customer contacts, pulling together all the data you might have about someone from all your different systems, so you can really understand, that customer, what products they have from you, maybe get a view of what they like, what they don't like, how they're related to other people. Even down to social media posts. Maybe they interact with you on social media, or maybe they're influencers. So what can we do with this sorts of data? How can we put that to use? So can you use it to improve the customer experience? Absolutely. Customer 360 View, kind of one of the fundamental things it's meant to do is help you improve your customer experience. Customers get very frustrated for obvious reasons when they interact with you and you don't have the information about them that they expect you to. When they contact you, they expect you to know what car they have, their claims history, any information you have about them, so on and so forth. So being able to interact with them intelligently with all the data available definitely improves their experience. Can you use it to identify high lifetime value customers? Absolutely. When you understand your customer's behavior, when you can see that context both in the past and currently, you can start to understand, is this a customer who, every 2 years buys a new car, at the top end with lots of options, and makes very few claims, versus someone who, buys their car much less frequently, makes a lot of claims, has maybe posted bad things about you on Twitter. Being able to combine all this information together to get a view of how likely your customer is to buy future products based on their past behavior. And then you can focus on serving those high lifetime value customers especially well. And this is kind of where the relationships come in into play as well as being very handy. If you know someone works, maybe is a C-level individual in one of your corporate clients, I'm not saying bribe them, but you would want to treat them well as your customer. If you give them personally a bad experience, then that could translate into your relationship with your corporate customer. And likewise, if you've got a high value customer, and then you have information about her husband, who's also a customer, maybe looking at him individually. He doesn't look personally like a high value customer, but you want to give him good service, as well as his wife, because as a unit together, they're both lifetime value is very high. Can you use the customer 360 graph to detect and prevent churn? Absolutely. So the same way that you can identify high value customers, you can also identify customers who are likely to churn. You can look at past behavior. Can you find patterns of claims, patterns of social media posts and customer interaction that have led to someone not renewing their contract or not buying another car from you? And then, can you find other instances of that pattern forming? Can you watch for instances of that pattern forming? So that you can identify potential churn. And then again, taking that together with your view of a customer's lifetime value, you can make decisions about how you want to interact with that customer and whether or not you want to go to great lengths to prevent that churn. And likewise, you can use the graph to improve upsell and cross-sell. You can identify what people are likely to buy, what sorts of options they like, compare that to other people who have bought similar products from you, maybe make recommendations about what other options they might want or features that they might want to add, or maybe try to get them to buy the next step up in a line of car based on what you've seen before, both in their behavior as well as the behavior of other people in the graph. And then finally, knowledge graph. So knowledge graph is quite an all-encompassing term, but we're seeing lots of uses for knowledge graphs, not just in this industry, but across many industries. Right? The idea is taking your company knowledge and combining it together so that you can see how it all links, which makes it easier to use. Can generate new insights because that data was never linked together before, and really gives you a way to kind of persist this, so it's not just in engineers' heads or on bits of paper or on a file system somewhere. So this is really taking a look at kind of a product-based internal knowledge graph. We could extend this to include more organizational data, HR data, so on and so forth. But this is big enough, I think. So we'll focus on more product type stuff here. So we have product at the heart of this. We can understand all the different variations of a product, how product families fit together, ultimately follow the documentation links to find out where this documentation is stored, and perhaps who owns it and who's responsible for it. And this can enable search engines. It can make it much easier to find information that you're looking for, when it just lives on maybe it just lives on a file system, isn't tagged or categorized in any way or really linked together. Putting it into this sort of review makes it much easier to work with, and that can be a real time saver, and save money, in fact, because you're saving time. Then down here we have again more of kind of a BOM view of a product, some parts and the assemblies they go into, and so on and so forth. We can see where this product is made. It could be in one facility or more than one facility, whether or not we have parts in inventory. We can see the supplier information for those parts here, just as we noticed earlier. Here we have more the claim information and fault information. We have marketing data and social media analysis that might be related to your brand or to your individual products. We have sales figures, sales forecasts. Bringing all this information together and making it linkable so that you can understand a full view kind of across all these different sets of data. So how can we combine these together to make use of a knowledge graph in this industry? So can we use it to improve your products and services? So absolutely. When you have access to lots of information, you might have documentation, design documents, notes, decisions, things like this stored for many, many, many years across all sorts of different offerings. And when you put that into a place where it's searchable, it gives you the opportunity to take those things into account as you're designing and building new products. So what worked in the past, what didn't work in the past, what was the solution to problem X that you're facing now? Um, even looking at suppliers and understanding how that maps to different faults and so on and so forth. Can you improve the things that are going into your products to reduce those number of faults? All these sorts of things can be understood from the knowledge graph and looking at the combinations and the relationships between the data in that graph. Likewise, in the same way, you can improve your product time to market, right? So when you can have the right documentation and the right understanding at hand, it means that you can finish your your design cycles and your engineering faster. It also means your engineers, people who might be looking for this data or need this data, aren't wasting their time searching for it and trying to figure these things out. Instead, they get the information they need quickly, which allows them to focus on on their actual job, the things they should be doing. Can we use that for customer-facing uses as well? Sure. If you create a portal that contains information about your products, documentation, historical information about your products that people might be interested in, you can expose all of that, externally as well, and give that, ease of use for that information directly to your customers. Again, improving their experience in the process. And then, of course, there's other use cases, like I said, that are less specific to the industry, but are applicable across a number of industries. So identity and access management, when you have your hierarchy information, your system information, your data maps, who has access to that and who doesn't. Infrastructure and network management, across your IT estate and your different facilities. Master and metadata management, mastering your data, understanding where it lives, where are the golden sources of data and how it moves through your systems. And then regulatory compliance kind of fits in with that. Depending on your industry, you might have data compliance. Everybody has GDPR compliance concerns these days. So you can also use the graph where you have compliance issues to help resolve those issues. So now we'll quickly take a look at a few case studies. These are companies that use Neo4j in some of the ways that we've talked about. So first there's Volvo. So Volvo uses Neo4j to understand the connections between every component in their vehicles and how that maps to a customer need. So not just viewing the BOM for the sake of being a BOM or for meeting particular engineering metrics, but really understanding how everything in the vehicle meets a particular customer need, which is quite an interesting use case, and I think probably involves quite a lot of data, highly connected data. We have the US Army. So the US Army uses Neo4j for supply chain optimization. So you might not think of them really as a typical manufacturer, but certainly they need to understand how they make repairs, what spare parts they need, where those have to go. And of course, in this sort of a use case, lives are really at stake. So having the right components, making the right pairs in the right place at the right time can literally save lives. So they use Neo4j to be able to understand their bill of materials, to manage their supply chain, and make those sorts of decisions much faster than they used to be able to using an old system. Then there's Schleich. So Schleich uses Neo4j to do integrated product data management throughout the value chain. So that's both looking at supplier information, things that that come from the materials that come from their different suppliers, and also as it moves through their entire production line, their entire company. So again, this gives them access centrally to all the knowledge they have about their different parts. The things that go into their different products, even how that matches up against regulations for particular materials in different countries. NASA. So again, perhaps not someone that you would think of as being a traditional manufacturer, but actually they use Neo4j for a lessons learned database that's used by their engineers and their scientists. They have loaded decades of documentation into a database, made all the connections between that information with Neo4j to understand the content of these lessons learned, what it relates to, the metadata about it, and then that's used to power searches so that their engineers and scientists can go back through those lessons learned and understand how previous problems were fixed. And in fact, one of the outcomes they highlight is that they used this search engine to find an issue for the capsule that they're building for Orion, the mission to take man to Mars. And the fact that they were able to find this information so easily literally saved 2 years and $1 million from the effort to send man to Mars, because they didn't have to re-engineer that. They didn't have to try a bunch of things. They were able to find the data that they needed straight away using the graph. And then Lockheed Martin. So Lockheed Martin uses Neo4j for Product 360. We talked about Customer 360 before. Product 360 is the same idea, but really looking at their products, understanding all the data that sits around their product and how it fits together. So having that 360-degree view of their product, has generated a lot of efficiencies for them, and is generated new insights so that they can use that to improve their products going forward. And really the power of all this, in my final slide, I'm trying to convey, we've looked at some very simple examples, some very small graphs that I drew by hand. The power of this comes when your data looks like this, when you've got a massive data set, highly interconnected, and you need to find these patterns across all of that data. That's where Neo4j really shines.